So this is an overview of your review for Unit 2 for Algebra 2. Now this is a very difficult unit on quadratics, so thank you very much for taking the time to make sure you did everything correct. Well, my tablet's not working, so give me a minute. Whoop, that's not what I wanted. Okay, I think I have it working now. So we are going to graph these parabolas, and they're in the three different forms: standard form, vertex form, followed by intercept form. This is section 5.1, so if you need to refer back to anything, then please do so. Standard form, I know that there's a formula, negative b over 2a, that helps me calculate the x value of my vertex. So for this particular parabola, negative b is negative 6, and then 2 times the a value would be 2 times negative 1. So negative 6 divided by negative 2 gives me a positive 3 for the vertex. Now to find the y value of that x value, you go back up to your formula and you plug in 3 for the x. Now remember, this negative coefficient is not being squared, so it's negative and then 3 squared plus 6 times 3 plus 1. So let's see, that is going to give me a 10. So at 310, we have our vertex, and we need to come up with a few more points. So symmetrically, I'm going to pick 2 and 4, and again, if I evaluate x equals 2 into this, substitute it in, we get negative 4 plus 12 plus 1, that gives me a 9. And the same thing will happen when I substitute in the 4. So 2, 9, and 4, 9. And then of course we graph the parabola. Whoops, missed, but you get the idea. So the last part underneath here, I don't know if you see it on your paper, it says what's the axis of symmetry. So our axis of symmetry is x equals 3. It would be the vertical line right here that would cut this parabola in half. And if you want to be extra thorough, you'll even draw in the the axis of symmetry. So you know you're correct. Number 2 is much better because in vertex form you can just see the vertex. The vertex is at positive 4, negative 2, hk. Now for the focus and directrix, remember focus, you get to use your formula sheet. The focus point is always at h, comma, and then k plus 1 over 4a. So for our parabola, the h is a 4, the k is a 2, plus 1 over 4 times the a value, and the a value in this problem is an invisible 1. So 2 plus 1/4 is 2 and 1/4. Oops, I think I have that wrong, don't I? Just a minute. No, actually I'm okay. I just had it wrong on my key. So 4 and then 2 and 1/4. You can either write 2 and a 4th, or you can say 2.25. Decimals are fine here. So, oh, I know what I did wrong. Back up. This is a negative 2, Abruzzo. This is not even close to correct. Oy. Negative 2 plus 1/4 is negative 1.75, which is negative 1 3/4. I'm so sorry, guys. It really helps if you have the right number down. Okay, the directrix formula is a line y equals, and then it's k minus 1 over 4a. So for us, the k, now I realize, is a negative 2, and then minus 1 over 4 times 1. Negative 2 minus 1/4 is negative 2 and 1/4. Again, decimals would be fine. Negative 2.25 is a good answer. And I don't know if you could see it at the bottom there, but the axis of symmetry is still x equals the x value of the vertex, which is x equals 4. Now, if I go ahead and graph this, 4, 2, you'll still need some other points, so we're going to have to do a t-table. If I choose a 3 and plug it into the original, I get a negative 1. And if I choose a 5, I also get a negative 1. Oh, goodness. Gosh, I'm on a roll today. I can't graph. 4, negative 2 is actually down here. 3, negative 1, and 5, negative 1. Sorry. All right, number 3. Intercept form means that you are factored, and you should be able to identify your two x-intercepts fairly quickly if it's already factored. So here we have a negative 5, and here you would have a positive 5. So I'm going to graph my two x-intercepts. That's where it crosses the x-axis. And I know the x value of my vertex is the midpoint of those two numbers. So negative 5 plus 5, whoops, that's a plus 5 up here, divided by 2. So 0 divided by 2 is 0. To find his y value, you go back up to the whole formula. You substitute in the 0, and you get negative 25 times 1/5, which is negative 5. So your vertex is at 0, negative 5. Now remember, you guys are well versed in how to use your calculator. So if you ever are stumped and you forget formulas or you forget how to find something, you can always go back and try your TI 84. The axis of symmetry is x equals 0 because that'd be the line that cuts it in half. Solving by factoring. You must show the work of solving by factoring. So first thing I notice, if this is a solving problem, I could divide by any multiples. So everything here can be divided by a 2. I'm going to change this problem to say x squared minus 8x plus 7 because that'll make my factoring much easier. That'll become an x minus 7 and an x minus 1. And when I solve both of those factors, this one gives me an x equals 7. Oops, that's a 1 right here. And this one gives me an x equals 1. So you're going to have to solve by whatever method I ask in each section. I notice that this factoring problem is a perfect square minus another perfect square. So this is the pattern where you just simply square root both of them, and then you put a plus in the first factor and then a minus in the second factor. So for us, square roots of both of these would be 8x and then plus 5 for the first factor, and then 8x minus 5 for the second factor. Now remember, we're still solving, so if I set this equal to 0 and solved, and I did the same for 8x minus 5, I would subtract 5 in this first one and divide by 8, so I get negative 5/8, and here I would add 5 and divide by 8, so I get positive 5/8. And because it wanted you to solve by factoring, you must employ that method. Okay, number 6 shouldn't be too hard to factor. How about an x minus 8 times an x plus 3? That would add up to negative 5. So when I solve my factors, I get x equals 8 and x equals negative 3. And then finally, we have another factoring problem. It looks kind of scary at first, but I notice that this is a perfect square and this is a perfect square. So that's kind of where I'm leading when I think about my factors. So I'm going to go with 4x for my first terms. And I notice everything here is a plus and a plus. So let's try positive 7 and positive 7. This should work if the outer plus the inner adds up to 56. So we have 28 plus another 28, and sure enough, that is 56. So when you set your factor equal to 0, and notice we have the same factor, so I don't even have to do this problem twice. I would subtract 7 and divide by 4. And the same answer I get both times is negative 7/4. Now this is a typo. I was supposed to change this question to say solve, and it's supposed to say x squared plus 121 equals 0. So apologies. This is how it looks on the test. Since there's only one x in this problem, I'm going to isolate him. So first I'm going to subtract the 121, and then I'm going to square root both sides. And negative 121 can break into 121, which is a perfect square, times a negative 1. So my answers are plus and minus. Square root of 121 is 11, and then square root of negative 1 is I. Okay, where's my, there we go. Now we have to solve by using square roots. And I notice in each one of these questions, there's only one thing that's being squared. There's only one variable component in each question. I want to isolate that. So first on number 9, we're going to divide both sides by 2. And we get x squared equals 18. I notice that some of you are doing the algebra right up until this point right here. You're not sure how to break down radicals. You need to go back and revisit 5.3 and how we broke down some radicals. You look for the perfect squares that will break into 18 or factors of 18. So I know that's a 9 left over times a 2. So my answers are plus and minus 3 left over square root of 2. Okay, number 10, we're going to add 8 to both sides. So we have 4x squared equals 48. And then I still want to isolate the x squared, so I'm going to divide both sides by 4. Okay, we have a similar issue here. We need to square root both sides, and it is going to break down. So when I think about 12, the perfect square that is a factor of 12 is 4. So my answers are x equals plus and minus always on a solving a square root problem. Square root of 4 is a 2. Square root of 3. You'll know you're right. If you type the square root of 12 in, you'll get a gross decimal. If you type 2 square roots of 3, you should get that same gross decimal. So if you're on a test and you're not sure if you did it right, you can always check it by doing a decimal match. Now on number 11, right away we need to square root because it's already isolated. And we've got an x plus 8 equals 24 is going to break into 4 times 6 because that's my perfect square. So plus and minus 2 square roots of 6. And the final step in this question is to subtract the 8 over. Now you're not going to be able to simplify this any further because you've got a whole number and then a radical number and they can't combine any further than this and there's nothing dividing them. Okay, simplifying in section 5.4 means we're going to have i's. So square root of negative 169, you can think of that as 169 times negative 1. Square root of 169 is 13, and this is an I. There is no plus or minus here because you are not solving, you're just simplifying. I want you to break this guy down into separate radicals. We have the square root of each of these. So the first two should be pretty easy. Square root of negative 81 is just 9i. Remember, square roots have little 2's here technically, and we're going to divide the power divided by the index of the root. So 8 divided by 2 is x to the 4th. And then same thing on the y's. What's troublesome about the y's, though, is it doesn't divide evenly. So you ask yourself, 2 goes into 7 how many times? And that would be 3 times with a remainder of 1. So anything that's a remainder, we're not going to divide evenly, stays inside the radical. I think a few of you need to practice this, judging from your last performance quiz performance. Number 9, we are just adding our like terms. There's nothing fancy here. So 9 plus a negative 12 gives me a negative 3, and then negative 4i plus 5i is a plus I. On number 15, you are simply subtracting your like terms. 12 minus 8 is 4. 15 minus negative 1i is 15 plus I, so that's a plus 16i. Number 6 has a little bit more complications in it because you need to distribute the coefficients into the parentheses first, so you really have a 12 minus 24i plus 7 minus 35i, and now you just need to collect your like terms. So 12 plus 7 is 19. Negative 24i minus 35i is negative 59i. Okay, good. 17, there's nothing, no symbol in between the two parentheses. That implies multiplication, which means we have a FOIL problem. Now these involve quite a bit of work, so please be careful. First times first is 15. Okay, 3 times negative 4 is negative 12i. 12i times 5 is positive 60i. 12 times negative 4, careful, is a negative 48i squared. There's a couple things. We've got some like terms right here, and we have to remember that I squared is really a negative 1. So you really have a negative 48 times a negative 1. So I think, let's see, that's a plus 48i when I collect those. What you really have on the back end here is a plus 48. Now you're still not done. You now have 2 more like terms you need to combine. So let's see, 50, 63 plus 48i. Now I have not worked out this key yet, so apologies if there's any stupid mistakes. I'm trying to go a little fast. Have you noticed all of our answers here have looked like a plus bi form? A plus bi, a plus bi, a plus bi. You're going to have that, and if you don't have a plus bi form, you're probably screwed up, unless one of the components is 0. Now for this, you have to multiply by the conjugate, remember conjugate, of the denominator. Conjugate looks a lot like the denominator, except it's got the opposite sign in the middle, so it'll be a 1 minus 4i. The reason you need a conjugate is because you need the i's to cancel out in the denominator. So in my numerator, I'm going to FOIL these together. I get 6, and then minus 24i plus 1i, and then minus 4i squared. Please don't try to skip steps on this question. On the denominator, you've got a 1, a minus 4i, and then a plus 4i, and then a minus 16i squared. So again, remember you've got like terms in the middles, and you also have to remember that I squared is really a negative 1. So what we really have is 6 and then a minus 23i. When I combine those, negative 4 times negative 1 is a plus 4. We'll fix this in a second. And the denominator, the i's cancel. That's what a conjugate always does. And you have a 1, that'll become a plus 16. So combining my like terms, I have 10 minus 23i over 17. And I would never leave my answer like that because it might reduce. This one doesn't reduce, but what I want you guys to get in the habit of is breaking them up into separate fractions, because it's likely that on your test they will reduce. So break them up. If they reduce, do it. If they don't, leave it like that. 19, we're solving. I notice there's only one variable in this whole problem. I'm going to isolate it. So we're going to add 8 to both sides. We get 3x squared equals negative 72. We're going to divide both sides by 3 and get x squared equals, I believe that's negative 24. I hope. And we're going to square root, and since this is in the 5-4 section, you can anticipate having i's in your problem. The perfect square goes first, the negative 1 goes in the middle, and then the leftover part goes last. So you have x equals plus and minus, because we're solving, 2i square roots of 6. I think some of you just need to spend a lot of time practicing reducing your radicals, especially when there's an I in it. Number 20, do not distribute ever into a binomial. Instead, you need to divide both sides by a negative 4. You now have x plus 7 squared equals, need some calculator work, negative 36. And then we're going to square root both sides. The square root of negative 36, he is a perfect square with a negative 1. So we have x plus 7 equals plus and minus. This becomes a 6i. And then last step, we're going to subtract the 7. Now because there's an I in this question, there's nothing more you can simplify. You can't combine this negative 7 and the 6 because the 6 is really a 6i. Okay. Next question. You must solve by completing the square. So when we complete the square, this is where you put the blanks in. Normally I would move the constant to the other side, but it was already there. And then to find what goes in the blank, you take half of your b term and then you square it. So half of 8 is 4, 4 squared is a 16. Now you're going to rewrite your trinomial as his factored form, so it's x plus 4 squared, half of this is plus 4, and then equals 28. Then we square root both sides. X plus 4 equals 28 breaks into 4 times 7. So we have plus and minus 2 squared to 7. And then your final answer, we will subtract 4 to the right hand side. Negative 4 plus and minus 2 squared to 7. Okay, 22. We weren't so fortunate. We do need to subtract the 24 to the other side of the equation so we can make room for completing the square. Negative 24, and we will add the blank over here as well. So half of negative 16 is negative 8, but then when I square it, I get a positive 64. And then when I write him in his factored form, half of negative 16 is a negative 8, quantity squared. And when I add those together, I get a 40. Okay, we're going to square root both sides. 40 is 4 times 10. So this breaks into x minus 8 equals plus and minus 2 squared to 10. We're going to add 8. And your final answer looks like that. There's nothing more you can do to simplify that. That is it. Okay. We want to rewrite the circle into standard form by completing the square, but we're going to do it twice because we have to do it for the x's and the y's. So remember, the constants need to stay on the right hand side, and whatever you added to the left, you have to remember to add to the right. So half of negative 2 is negative 1, squared is 1, add it to both sides. Half of 6 is 3, 3 squared is 9. So we're going to factor this part, we're going to factor this part, and we're just going to add these 3 together. So we have x minus 1 squared plus y plus 3 squared Negative 1 plus 1 plus 9 is 9. So the last step here is to identify your center and your radius. Your center is at positive 1, negative 3, and your radius is the square root of 9, which is 3. So you will get multiple points on this question, writing the equation correctly and then identifying the center and radius. This question looks complicated because it's the electricity stuff with the impedance, but all they tell you to do is add these complex numbers together. So it's really a very easy question. You're just adding 7 plus 4i. If you want to put it in parentheses, that's fine. And then you're adding 12 minus 6i. So, whoops, you're adding your like terms together, basically. 7 plus 12 is 19. 4i plus negative 6i is negative 2i. And it's ohms for a label. And that's your answer. So that actually is a really easy question. Okay, this one was on several quizzes, and I'm not happy with what you guys did on the quiz, so pay close attention to this now. The area of the rectangle is 117. To find area, you need to multiply length times width. Now, what some of you are forgetting is when you multiply 2x minus 5 times x, you have to distribute the x to both parts, and it's supposed to equal 117. So when I distribute the x, I get 2x squared minus 5x equals 117. Now you have a quadratic, you have 5 different ways you can solve this. You could factor, you could do quadratic formula, you could do completing the square, although it won't be very nice. You could do, well, square rooting won't work unless you complete the square. You could use your calculator if you remember how to do that, but most of you guys will refer back to factoring. It's kind of a gross problem because it takes you a minute to try to figure out how to factor this one. So on your calculator, you start dividing 117 by his factors, and I think it factors into 2x plus 13 and x minus 9. Now you should notice when you solve these factors, this one is going to be extraneous because it's going to be a negative value, and you can't have a side of a rectangle who's negative, so the only acceptable answer is x equals 9. And if you plug that back into the dimensions of the rectangle, you get 9 meters by 13 meters. The important part of this question is solving your quadratic, coming up with the quadratic. If you just figured out 9 by 13 because you plugged and chugged until you got one that worked, you're not going to get your credit. And then this is a dropping problem because there's no velocity, it's not projectile motion. We have a formula that is given to you. Remember, h is the final height, and h sub naught is the initial height, or the starting height. So 214 feet high is the initial height, and they want to know how long it takes for it to fall to the bottom. So your final height is 0. You have negative 16 t squared plus the initial 214. Now at this point, you could either use your calculator, but I think it might be quicker actually to solve by hand. I'm just going to add the 16 t squared over here. You could have subtracted 214, it doesn't matter. It's going to work out the same way. Since there's only one variable in the question, I'm going to isolate him, so I'm going to divide by 16. And I get t squared equals, let's see, 13.375. And then final step, we're going to square root both sides. So square root gives us roughly 3.7 seconds. And it doesn't tell us where to round, I don't think, so I will take a few different answers. Okay, we're going to need a graphing calculator for this problem, so let me go grab my graphing calculator real fast. Okay, so our graphing calculator, we need to program it to have the function inside y equals, so let's do that. Negative 16. And we're going to use x's instead of t's, but it doesn't matter, it's just a variable, plus 45x plus 8. Now the first question says, what's the initial velocity? You can actually just read the problem, or read the equation, and realize that the number that's with just the t is my initial velocity, so the 45 is the answer to that question. So, part A, 45 feet per second. Part B says, what's the maximum height, and at what time did it reach that height? So if we are going to graph this in a standard window, we're not going to see very much. We don't see part of the parabola that we need. So I'm going to go and adjust my window so it makes sense. Remember, the x value is time, so I don't really care about back to the future time, so I'm just going to start at time of 0. And judging from my last graph, it looked like 10 was a sufficient amount of time. In fact, 10 is probably too much, so you could even come back to like 7 seconds. That'd be fine. For the height, I'm thinking -2 is plenty low because that would be even below ground. I definitely wasn't high enough in my window, so I'm going to try 50. That might be an overestimate, and we'll see. Now when I hit graph, oh, that's actually a pretty good estimate. I can see the path of the ball, and I can see when it hits the ground. Now the question is, what's the maximum height and when did it get there? So we need to find the maximum height on our calculator. We're going to use the calc menu. So second, trace, and you're going to go down to choose number 4, which is called the maximum finder. And then it says left bound question mark. Now notice right now my cursor is way down at -167, which is like way down here. Can't even see it. So scroll to the left for a really long time until you start seeing your cursor. There he is. And drag him so that he's a little bit to the left of your vertex. And once you're there, hit enter. And then scroll back to get to the right, like it's suggesting here, right bound. Hit enter. And then guess, just hit enter one last time as long as you haven't moved too far away. And we get 1.41, comma 39.64. So maximum height is the y value, so you'd write 39.64 feet, and it occurred at 1.41 seconds. Now the second part of this question says complete the table. We already have a table. Our calculator does it for us. So we're going to go to second table, and if your table's not set up to automatically fill in, remember you need to go to second window and play with your table setup so that it looks like mine. So go back to your table, and at time of 0 it's at 8, time of 1 is 37, and time of 2 is 34. So 8, 37, and 34. And then it says find the average rate of change from t equals 1 to t equals 2. These are ordered pairs technically. It's a 1, 37 and a 2, 34. So the average rate of change is really code for finding slope. Even though it's not linear, we're going to treat it like it's kind of linear, even though we realize it isn't. So y2 minus y1 is 34 minus 37, and then x2 minus x1. So we get a -3, and then the label, remember, it was y's over x's for slope, so it's feet per second. So what that means for us is, whatever this is, a ball is dropping or going down 3 feet per second between time of 1 second and 2 seconds, on average. Okay, good. Let's keep going. Solve using the quadratic formula. You are not going to be given the quadratic formula. You must know it. So quadratic formula is -b plus and minus square root of b squared minus 4ac all over 2a. So opposite of b is 8 plus and minus square root. I don't want you guys to write -8 squared because some of you are not putting your parentheses down. Instead, just go ahead and square him and make him at 64 minus 4 times a times c. And then big fraction bar, everybody's up above the fraction bar, 2 times a. Now you're going to simplify this. You're going to get 8 plus and minus square root of, and I'm going to type what's under the square root, 4 times 3 times 5. And I get square root of 4 all over 6. Now this is far from done. The square root of 4 is an actual whole number. It's 2. So we have 8 plus and minus 2 over 6. Because we no longer have radicals, I need you to give me your 2 answers. 8 plus 2 is 10. 10 divided by 6 is 5/3. 8 minus 2 is 6. And 6 divided by 6 is 1. I need you to take this all the way to the final answer. Okay, next question. Same formula. -b plus and minus square root. b squared would be a 25 minus 4 times a times c all over 2 times a. So let's simplify what's underneath the square root first. 25, get a 57. That's actually good news. 57 doesn't break down at all into any square roots, so this is your answer. That's good news. And then number 30, negative b plus and minus square root. B squared would be a 9 minus 4 times a times c, all over 2 times, whoops, it's a 4, 2 times a. So negative 3 plus and minus, type 9 minus 4 times 2. So that's 9 minus negative 23. Okay, not too bad. All over 8. We're not done because negative 23, although the 23 doesn't break down, you can pull out an I. So a final answer is negative 3 plus and minus I times the square root of 23, still in the radical, all over 8. Now, since there's no chance of anything reducing here, 3 and I and 8, I'm going to leave it as one fraction like that. Okay. When a quadratic function has only one real solution, it only touches the x-axis once. In other words, it bounces off the x-axis. Now, if you want to draw yourself a picture of what that looks like, it would come down, it would hit the x-axis, and then bounce right off. When it has two solutions, it would intersect the x-axis twice. So a picture of that could look like this, where it crosses here and here. Two solutions. And then two real solutions. And if it has two imaginary solutions, it will never intersect the x-axis. So it could look like this, where it just is way up here and will keep going up and never come back down to the x-axis. Or it could be an upside down parabola that happens to be in the lower half of the four quadrants, excuse me. Okay, graphing this parabola. You need to identify where your vertex is. Now you got several ways you can do that, but I could tell pretty easily that the h is a 0 and the k is a 4. Or you could use some other formulas, or you could use your calculator to plot these parabolas. So the vertex is at 0, 4. And then coming up with some other ordered pairs. I've noticed that some of you are not plugging in your numbers properly, and that's your issue. When you plug in a -1 into this formula, you get a negative coefficient, but then it's only the -1 is being squared, plus 4. So that'd be -1 plus 4 is 3. And then 1 is also going to be a 3. And I notice also that this is going to be a dashed parabola. So when I graph this guy in, it's going to look something like that. Now the final thing we have to do is we have to test a point. And you have to test a point that's either obviously in or obviously out of the parabola. And I like 0, 0 as my test point, because he's easy to plug in. So if I test the point 0, 0, 0 for x and 0 for y, I say, remember f of x is really just a y, I say 0 less than -0 squared is just 0, is 0 less than 4. And that is a true statement. 0 is less than 4, which means this is my solution section of my graph. I'll give you a little heads up. On the test, there's only one question of this, and it's a matching question. So you should be able to use a little bit of your calculator, a little bit of your brain, and get it right pretty easily. This next question, in order to find the vertex by hand, it's in standard form, so you'd have to do -b over 2a. So -4 over 2 times 1. Now the vertex is at -2, comma, and let's see, if I plug -2 in, I get 4 minus 8 is -4 minus -7. 2, -7. And then to make a t-table, oh, I already did it again, guys. -2, 7. Goodness. -2, -7. If I try a -3 and a -1, I'm going to do -1 first because that's easier. 1 minus 4 is -3, minus 3 is -6. Alright. I was a little dangerous in not checking the other point. You should always check the other point. Now this is a solid parabola because it's got an equal to bar. Whoops, kind of missed. And then a point that would be really easy for me to test, in my opinion, would be this point right here, which is -2, 0. So if I test the point -2, 0, That means I put a negative 2 in for the x and a 0 in for the y. I get 0 greater than or equal to negative 2 squared is a 4, plus 4 times negative 2 minus 3. So let's see. 0 greater than or equal to negative 8, negative 4, negative 7. And that is a true statement. So I'm going to shade in the parabola. Okay. Again, on the test, it's just a matching one. Now you should notice the next two questions are very different. There's no longer a y in these problems. You need to solve them, find the critical points, and then either use a number line to identify where they are positive and negative, or you could look at the graph itself. I get the feeling that most of you like the number line approach, so that's how I'm going to do this. First issue, I notice, this is not in standard form. I would have to subtract the 56 and say less than 0 to be able to factor this. So we're going to factor now to find our critical points. And we would get an x plus 8 and an x minus 7. So my two critical points are x equals negative 8 and x equals 7. That would be the point in which my function, we cross the x-axis. So if I put them in number line, whoops, that's an 8, number line order, I get 3 sections. So I need to test something that's way over here, something to the left or less than negative 8. So I don't really care what you test, but I'm going to test a negative 10. So when I put a negative 10 into the original problem, or this problem is fine too, I get 100 minus 10 is 90. 90 minus 56 is 40, so I don't know. It's something positive. So this is the positive answer over here in this section. Now something in the middle here to test would be the number 0. That would be very easy to test. 0 plus 0 minus 56 is a negative number. So negative. And then of course if I test something bigger than 7, I know it alternates, so this is going to be a positive section. The question originally was, where is your function less than 0? So the question is, where is your function negative? I see there's only one section on this number line where I got negative numbers, and that was this section right here. So between negative 8 and 7. Now here's the issue. You have to decide whether to put parentheses or brackets, and because it is not equal to 0, they just want to know less than 0, I'm going to use parentheses. So the interval for that question is negative 8 to 7, not including the endpoints. We're going to do something very similar here on 35. It's already ready for us to factor, so x minus 9 times x plus 5. So my two critical points are x equals 9 and x equals negative 5. So on the number line, in number line order, so negative 5 first and then the 9 next. I'm going to test some values over here to the left of negative 5. So I'm going to test, negative 6. So negative 6 squared is 36. Negative 4 times negative 6 is plus 24. So let's see, that's 60. 60 minus 45 would give me a positive answer. And if I test 0, remember these should alternate. 0 minus 45 is obviously a negative answer. And then I'm guessing it's going to alternate to a positive after that. So the question on this guy was, when is my function greater than 0 or equal to 0? So I want to know where it's positive. So the two sections where it's positive on this number line are this section and this section. So writing those as intervals, I would say it goes from negative infinity to negative 5, and because they also are including zeros, I'm going to put a bracket on negative 5, and then jump over all this stuff because it's negative. And then another bracket, pick up at 9 to infinity. And that is your interval. One more. Solving this quadratic. We know we have to first square both sides of the equation. Now remember, square rooting and squares cancel each other out. That's easy. But x minus 4 squared is 2x minus 4's multiplied together. So when you FOIL that, you get x squared, and then minus 4x is negative 8x, and then negative 4 times negative 4 is positive 16. So we have a quadratic that we are going to have to solve. I'm going to subtract the x. I'm also going to subtract the 8. So we get 0 equals x squared minus 9x, and then plus 8. Remember, I told you, every one of these 7.6 questions should factor nicely. If you get something that doesn't factor nicely, you did something wrong. So right now, I supposedly have two answers. I have x equals 8 and I have x equals 1. If I go back up to my original question, if I plug in an 8, I get the square root of 8 plus 8 equals 8 minus 4. So the square root of 16 is 4, 8 minus 4 is 4. Check, that works. But look what happens when you plug in the 1. You get square root of 1 plus 8. Does that equal 1 minus 4? Well, I already know this isn't going to work because this is going to be a negative 3. And the square root of 9 is positive 3, which does not equal negative 3. So this is an extraneous solution. You're going to show me you get it. You're going to cross it off. You're going to write EXT. The only answer to this question is x equals 8. I know that was fast, and that was very long. That's how long your test is going to be. So that is why I need you guys to be very proficient at every type of question on here. You can't afford to spend 5 minutes trying to remember some formula. It's not going to be a good use of your time. So please come in and get some help, do extra problems, watch this again and again and again, laugh at all my stupid mistakes, and good luck on your test.